In this section, we're going to look at linear, exponential, and quadratic applications in word problems. And so first, before we begin, let's talk about when you would use linear. Linear is when you have a beginning point and there is a constant rate of change, whether it's adding the same amount or subtracting the same amount each time. But we know that you're going to have an initial amount and then it's going to be a constant change. For an exponential function, you're still going to have an initial starting point, and then you'll have a common ratio that is continually multiplied or divided, depending on whether it's growth or decay. Okay? And then your quadratic equation is used to model situations where a value can reach a maximum point or a minimum point, or sometimes you would multiply two linear equations to get that quadratic. So we'll take a look at what that looks like. All right. So we're going to start with linear equations, and I know you guys are an expert on linear equations. So let's look at this one. And again, I like my 3 sections. We're dealing with word problems. All right, a 10-inch candle burns at a rate of 3/4 inches per hour. So my initial height of the candle is 10 inches. So my beginning point is 10. It is burning at a rate of 3/4 of an inch. So if it is burning, is it going up or is it going down? It's going down. It's burning. So my slope is going to be -3/4. Now remember, I want you to identify your x variable and your y variable. So because it's per hour, I know change in y over change in x. X is going to represent hour. Y is going to represent inches. And my equation, of course, is going to be y equals -3/4 x plus 10. That's my equation. So now it wants me to find the height of the candle after 5 hours. Well, where am I going to plug in 5? Am I going to plug it in for hours or if I'm going to plug it in for inches? Hours, hours. So hours is 5. So y equals -3/4 times 5 plus 10. And I get y equals -15/4 plus 10, which is really -3 3/4 plus 10. So it's really 6 1/4 inches after it's done. So 6 1/2 is a quarter. 6 1/4 inches after 5 hours of burning. And then, of course, you would write that over there. 6 1/4 inch after 5 hours of burning. Okay. Let's look at number 3 real quick. I'm not going to do all of it, but I want you to remember how to do them. So Henry is heating water for a science experiment. After 5 minutes, it's 76 degrees. After 8 minutes, it's 91 degrees Fahrenheit. If the change in temperature is constant, write an equation to represent the temperature of water after n minutes. Then find the number of minutes it will take for the water to boil. So in this case, 5 and 8 stands for minutes, so x stands for minutes, and y stands for degree in Fahrenheit, okay? Now I have 2 points. So remember, when you have 2 points, you can find your slope. So your slope is your change in y. 76 to 91 is 15, and then 5 to 8 is 3. It's adding 3, so my slope here is 5. Now I have a slope. And now I have a point, so I'm going to use point slope form. Y minus y1 equals n times x minus x1. And I plug in values. I'm just going to use this guy. So y minus 76 equals 5 times x minus 5. Y minus 76 equals 5x minus 25. You add 76 to both sides. And I get y equals 5x plus 51. Okay, so that's what my linear equation, I said I wasn't going to do this one, but I guess I can't help but do it. So y equals 5x plus 51. I know that x stands for minutes and y stands for degrees. So it wants me to find the number of minutes, so I'm finding x for how long it will take water to boil. Well, first you have to know at what temperature does water boil. And 212? I think it's 212. 212 degrees is when water, I think that's right. Okay, I'll double check, but I think it's 212 degrees. So I'm going to subtract 51. So divide by 5. and x equals 32 and 1/5 degrees. So about 32 minutes. 30, not degrees, that is 32 and 1/5 of a minute. That's how long it's going to take for the water to boil. All right, let's take a look at what happens when we have a quadratic or exponential. Okay, so when we have an exponential right here, it says Alexis put $75 in a new bank account. So that's my initial amount. So my A value here is going to be 75. Each year thereafter, the total balance in the account tripled. So my B is going to be 3. That's my constant term. And then write an equation that represents the balance. Okay, so my equation looks like y equals 75 times 3 to the x power. So now I'm going to use my calculator. And it says, write an equation that represents the balance of the account after her initial deposit, then find the balance of the account at the end of 2025. So it started in 2012, it ended in 2025, so X is going to represent 13 years, that's the years, and I am just going to put this in my calculator. Now, I'm going to do 3 raised to the 13th power times 75, and wow, she is going to have, that's a great account to have. Okay, this is how much money she will have. She will have $119,574,225 at the end of 13 years. I hope everybody's bank account is going to look like that. I have not found anything where it triples each year. Amazing return. So that's the amount. Okay, over here, remember you have to recognize from a table of values. So my initial amount is $120,000. The value of the boat and its age is given. Man, that's a cheap boat back then. Is given at the table to the left. Assuming the trend continues, write an equation to represent the value of the boat when it is X years old. Then find the value of the boat when it's 8 years old. So my initial amount is going to be $120,000. Now, how these numbers are big, I can't do them in my head. So what I'm going to do, I know that it's going down. So I'm going to take, in my calculator, I'm going to do 87,480 divided by 97,200. And that's going to give me that I'm multiplying both by 0.9. Okay? So that's how I found it. And then I'm going to test it. If I do 97,200 divided by 108,000, I'm still going to get, so it's going to be the same. It's going to be that common ratio. So my common ratio is going to be 0.9. So my equation is going to be y equals 120,000 times 0.9 to the x power. Okay? Now, it wants to know when it's 8 years old. So now I'm going to do 120,000. So I'm going to do 0.9 to the 8th power. Then I'm going to multiply it by 120,000. And so after 8 years, the boat is going to be worth $51,656.07. That will be the value of my boat. Okay, now let's look at quadratic equations. So remember, you have two cases when you have quadratic equation. You have a vertex form, and then you have the P and Q form when you're given your x-intercepts. So a volleyball is served from a height of 3 feet. Then 0.75 seconds later, it reaches a maximum height of 12 feet. So that's my max. So at 0.75 seconds, it reaches 12 feet. So X is going to stand for seconds. Y is going to stand for feet. And a volleyball is served from a height of 3 feet. So the random point that I'm going to use in this is at 0 seconds, it's 3 feet. That's my random point. That's my vertex. So now, you know this is H, this is K. Remember what you're trying to do here. You're trying to find that A value. So I'm going to use y equals A, x minus h squared plus k. And there's my random point. So I have 3 equals A x is my random x, minus 0.75 squared plus 12. So I'm going to do negative 0.75 squared is going to be 0.5625a plus 12. Then I'm going to subtract 12 on both sides. I get negative 9. And when I divide this on both sides, I'm just solving for a. That's all I'm doing. So negative 9 divided by 0.5625. I'm going to get an a value of negative 16. So I found my a value. Now I need to find my vertex form. So a is right here. So now I do y equals negative 16 x minus 0.75 squared plus 12. That's my vertex form. I need to find it in standard form. So I'm going to do double distribution. So I'm going to do that over here. So I get x minus 0.75 times x minus 0.75, and I get x squared minus 0.75x minus 0.75x plus 0.5625. So when I combine my like terms together, I get 1.5. So I get x squared minus 1.5x plus 0.5625, and then plus 12. So all I've done is I've double distribution, and now don't forget you've got to multiply that a value times everything. So we're going to distribute that a value plus 24x. I'm multiplying here, and I get negative 9 plus 12, because that's my k value. So my standard form of the equation is this right here. Okay, so now that I have found my standard equation, and taken a while to get there, then it says find the height. Well, remember, height is y, so I'm finding y after 1.5 seconds. So now I'm going to plug in 1.5 for x, and that's going to tell me the height. So 1.5 squared times negative 16 gives me negative 36. 2 times 1.5 gives me 3 plus 3. And then that is... I messed up. This is 24. I wonder that was kind of looking weird. This is 24. I didn't bring the 24 down. 24. I knew something was funny. Okay, so this is negative 36, and then it's 24 times 1.5, and I get plus 36 plus 3. So those cancel out. So after 1.5 seconds, the ball will be 3 feet. After 1.5 seconds, the ball is going to be 3 feet. So that's what it looks like when you have a vertex, okay? Now, look at number 7. These are a little bit easier. This is when two linear equations multiply together. So the length of the rectangular blanket. So there's a picture of a rectangle, so let's draw it. We have the length and we have the width. It says the length of the rectangular blanket is 3 inches longer than twice the width. Who's not being talked about here? The width. So I'm going to make the width be x. And the length is 3 inches longer than twice the width. So those are the dimensions of the blanket. If the blanket has a width of w inches, write an equation to represent the area of the blanket. Well, how do you find area? It's base times height, length times width. So it's going to be 2x plus 3 times x. And when I distribute, I get 2x squared plus 3x. So the area of this blanket, all I have to do is write the equation, is going to be 2x squared plus 3x. So this is what the applications look like. We'll be doing this more in class, but if you're struggling with this, catch me sooner rather than later.